Okay, Assalamualaikum everyone. So today we're going to proceed with the next chapter of 6.2. Okay, the second subtopic of the last chapter for Physics Form 4, which is total internal reflection. Pantulan dalam penuh. Okay, so before we go further, as usual, we have to know what we're going to learn in this subtopic. So our learning outcome is describe critical angle and internal reflection. So at the end of this lesson, you're supposed to know what is critical angle. Make sure you can explain and calculate, and also you can describe what is total internal reflection. Okay, 6.2.2, you have to relate critical angle and refractive index. Okay, this is where the Snell's law come from. Okay, we learned before Snell's law in the previous subtopic. The last part is communicate and explain natural phenomena and application using total internal reflection. Okay, this part will continue in the next video. So for today, it's just about 6.21 and 6.22. Okay, ready? Okay, so have you ever come across this situation before? Okay, when your dad or your mom drive a car or you were in a motorcycle, so you can see there looks like water on the road. Kita nampak macam ada air dekat jalan raya tu kan. Okay, tapi bila kita gerak semakin dekat dengan benda tu dah hilang. So it's disappeared. So this is called mirage, or bahasa Melayu kita panggil logam maya. Kalau lebih besar kita panggil fata morgana. Okay, all the same thing. So this one is not really happen. Okay, but how it happens? So this is what we're going to discuss. Okay, the same goes to, okay, kalau tengok cerita pasal Arab-Arab di padang pasir Mesir kan, atau tengok cerita Fir'aun ke, okay, Scorpion King ke. So you can see kalau dekat tempat panas ni macam desert. Okay, you can see it's a fake lake. Nampak macam ada air kat bawah tu. Tapi bila kita pergi dekat-dekat, penggambaran pergi-pergi, tengok tak ada air. So what is that? Itu sebenarnya bayangan awan jatuh ke tanah, ke tempat yang panas. Okay, so this is one of the natural phenomena of what we call internal reflection. Okay, total internal reflection. Okay, in application, so what is this? Nampak canggih kan? Okay, so this is what we call fiber optic. So kalau tengok kat rumah tu ada unifier wifi, so dia ada satu kabel halus je. Okay, yang tu lah kabel fiber optic. Means this cable kita tak pakai kabel elektrik, kita pakai optik, so dia akan transfer data with the speed of light. So macam mana dia transfer? Dia akan pantul. Internal total reflection. Okay, so the application part we're going to discuss on the next video. So again, we're going to discuss the first and second part only. Okay, so what is total internal reflection? Okay, as you can read over here, so total internal reflection is a phenomena that happens when a light hit a boundary and then it returns back. Okay, supposed to be when you have a glass, kita belajar tajuk sebelum ni, refraction, pembiasan. Kalau cahaya kena satu kaca, dia akan terbias. But in this case, dia tak terbias. What happened? Dia patah balik, reflected. How can it happens? Dia bukan cermin. Kalau cermin baru cahaya dipantulkan. Tapi ada case tertentu when you put the incident ray at certain angle, so the light will reflected totally. Tak ada langsung yang reflect. Macam tak percaya kan? Okay, tak percaya kita kena buat eksperimen lah, nak tunjuk benda ni baru percaya kan? Okay, so this is the example. As you can see, yang mula-mula ni kita bagi cahaya. Dan bila cahaya tu, okay, let's say yang biru tu is water, yang atas tu is air. So what happen? When light is incident, then light is refracted, fully refracted. Okay, then we change the angle. Okay, 50 degrees. So you can see 20 degrees refracted. Yang ni semua Snell's law, dah belajar kan? Menjauhi normal atau mendekati normal. Okay, then we change to 30 degrees. So you can see refracted 42 degrees. Then until we go to 45 degrees, refracted. Okay, the last part, you can see yang kat atas tak ada. So all of the light is fully reflected. That's what we call total internal reflection. This sepatutnya refract, tapi kita bagi kat certain angle, dia reflect. Okay, so what is the proof? Of course, the proof we have to conduct an experiment. Okay, before that we have a condition. Dia bukan boleh suka-suka jadi. Asal agak-agak, oh jadi. Agak-agak bubuh, light tak jadi. So tak boleh agak-agak dalam fizik kan. So you have to have exact numbers. Okay, kita kena buat eksperimen. Okay, so dia ada syarat-syarat dia. So yang pertama, optical dense to less dense. So cahaya tu mesti dari denser medium, means optical dense means yang cahaya susah nak masuk. So maksudnya dari kaca ke udara, dari air ke udara. Kalau air ke kaca tak boleh. Dia lagi tumpat ke kurang tumpat. Tumpat ni bukan ringan ke berat. Tumpat in this case is optical dense. Okay, optical dense lagi susah cahaya nak masuk. So you must from a glass to water or a glass to air or water to air. So that's the first condition. Okay, the other way around tak akan jadi. Okay, number 2, angle of incident is greater than critical angle. Okay, angle of incident is cahaya yang kita tuju tu mesti lebih besar daripada sudut genting. Okay, what is critical angle? Okay, critical angle is the angle where refraction happen at 90 degrees. Okay, kita bagi incident light, so kita tengok dia refract sepenuhnya, bias sepenuhnya means 90 degree. Tadi kan dia refract sikit, dan dia refract sepenuhnya 90 degree. Lebih daripada tu baru total internal reflection happen. Ketika 90 degree, that is critical angle. So we have to know the critical angle in order to make total internal reflection happens. Okay, so I'll show you an experiment. Okay, we're supposed to conduct this experiment in our lab. So unfortunately, bila sekolah buka apa kita tak tahu, banyak eksperimen kita nak kena kampung balik lah. Okay, so I'll show you, no problem with that. Okay, this is the experiment that we're supposed to conduct in our lab. So what should we do? So we take a slide. So kita ambil satu kaca. Kita tengok yang separuh bulatan ni, ini kaca. So kita bubuh kat kertas putih, dan kita bagi ambil sinar cahaya, kita tembak. Okay, tembak betul-betul dekat zero tu. So that you can see dekat atas ni, you akan nampak refraction of light. Okay, so ambil angle dia. Lepas tu ubah sudut sampai refraction ni 90 degree. Okay, 90 degrees. Lebih daripada tu, that is where total internal reflection happen. Ketika 90 degree, that is critical angle. Okay, so please observe this experiment carefully. Okay, that's the ray box. Okay, this is what we draw. Okay, now you can see we place a glass over there, then we use the ray box. Okay, that is the incident light. Okay, you can see over there nothing happened. Okay, because the light is at normal 90 degree. Then we increase the angle, so you can see the upper part is the refraction. Okay, so we increase the refraction take place. The refraction take place. Okay, so the higher the angle of incident, the higher the angle of refraction. That is Snell's law. Okay, until certain part from here, you can see the refracted light is 90 degrees. Okay, so let's wait. Okay, when refracted light is 90 degree, that is the critical angle. Then when it's larger than that, okay, this is total internal reflection. Okay, you can see we increase. Dah tak ada lah refraction kat atas ni, semuanya reflect. Okay, yang ini semua sekarang ni proses total internal reflection lah. Okay, so asalkan you lepas critical angle, dia dah tak ada refraction lah, semua di-reflect, dipantulkan. Okay, so this is very easy experiment, you can try on your own. Okay, very interesting as well. Okay, so this is from the textbook. Okay, so I already explained just now. So the first part, you can say A, when incident light. Okay, we have small incident angle, then you can see the refraction up on the upper part. Okay, then when the refraction is 90 degree means that is the critical angle. So kalau 40 lah critical angle. So if your incident angle more than 40, okay, so you akan jadi daripada jalan ketiga ni. Okay, so semuanya dipantulkan. Dia faham lah? So this one baca balik je lah. So make sure you susun ayat tu betul-betul. Okay, go to the next part. Does critical angle depends on refractive index? Okay, critical angle ni bergantung tak kepada indeks biasan. Kalau kita ada 10 jenis kaca, semua critical angle sama ke? Ataupun kaca lagi tumpat, lagi tinggi atau lagi rendah critical angle dia? Okay, this is what we're going to discuss. Okay, we're supposed to conduct one more activity. Okay, this one's in your textbook as well. We're going to apply the Snail's law, what we have learned that in the previous lesson. Okay, so we're going to change types of glass. Okay, glass blocks yang berlainan refractive index. Ada 1.5, ada 1.8, ada 1.6. So, kita bagi pada sudut yang sama, kita tengok jadi ke tak pantulan dalam penuh. Okay, jadi ke tak sudut genting dia? Semua sudut genting sama ke? Okay, so we're supposed to conduct this experiment. Then we can do a relationship. Tadi kita punya learning outcome kita kata relate refractive index and total internal and critical angle. Okay, so from the textbooks, so I get it from this textbook. So what do we have over here? After we do the calculation, simple comparison of Snail's law. So we have n equal to 1 over sine c. So c is the critical angle. Okay, for example, if the refractive index of the blocks is known, 2.42, so c sine c equal to 1 over 2.42, so you get the refractive index is 24.4 degrees. The critical angle. So you must be greater than 24.4, then total internal reflection take place. Equal to tak jadi, dia kena greater. Okay, so we can conclude that critical angle of medium depends on optical density of the medium. The higher the refractive index, the smaller the critical angle. Means kalau ada satu gelas, dia punya refractive index 1.5, satu lagi 2.5. So yang 2.5 tu lagi senang kita nak buat. Means critical angle dia lagi rendah daripada 1.5. 1.5 mungkin 42 darjah, yang 2.5 20 darjah. So awak buat 21, dah dapat total internal reflection. Okay, so hopefully you understand. If I go too fast, so just watch and watch again as usual. Okay, do you need to memorize this equation? Okay, no need to memorize. How this equation come from, where it comes from? So this is from Snail's law, 6.1, refractive. Okay, so Snail's law states that incident light and refractive Ni sin I means refractive index, the incident part, the first part. Sin I means angle of incident. Then you have the second refractive index or second medium. Then sin R is refractive angle. Okay, so from higher optical dense to less optical dense, usually air. Okay, so from glass to air, for example, so air N2 is 1, then it happens total refraction at 90 degrees, sin 90 also equal to 1. Okay, so you rearrange, I becomes C, critical angle, so you get the equation N equal to 1 over sine C. So again, you don't need to memorize this equation, just understand the concept of Snail's law, which is incident, which is refractive, which is the first medium, which is the second medium. Okay, so I don't like, saya tak suka hafal equation, hafal tapi tak faham, jadi robot nanti kan. Okay, any question? Alright, if there is no question, so thank you. We will discuss about the application and phenomenon and few exercise in our class later. Okay, thank you. Bye.